Alright, so again, rotations, just like your translations, the slide, and the reflections flip. For some of you, you're able to see it visually. For some of us, we struggle with that. So we're going to take a look at both ways. Now, this first one I told you to do as clockwise. It says rotate the image 90 degrees about point P. So I should be expecting to see this triangle flip down. Now you can kind of think of P as your origin, if you would. So my triangle here should flip down like that. And since it goes through the triangle, my triangle should go through kind of this horizontal line here. So approximately it would look something like this. E prime, A prime, and C prime. And again, we would label that with the prime. Okay. So again, it's that triangle, gets reflected out, or gets rotated out. Now, rotate the image 180 degrees about the point P. Here, P is actually on the shape, so we can still think that kind of as our origin. When this gets rotated around, what happens to the shape, essentially? It essentially flips upside down. It looks like that reflection. 180 degrees looks like that reflection, but what changes? Good, yeah, the order of the letters. M and L are going to kind of flip-flop. So M will come around to the left side, and L will come around to the right side. And P stays put. Okay. So clockwise, remember, is this direction, counterclockwise this direction. Now what if I asked you to rotate this 180 degrees clockwise? What would you end up with? It's the same thing. Clockwise, counterclockwise, 180 degrees gives you the same result. It's basically halfway around your circle. Alright, now rotations. Let's see if we can kind of come up with the rules here. Let's see how you guys do with this. Alright, so let's say that we have, starting out, the point 1, 4. Alright, so starting off the point 1, 4, if I wanted to go 90 degrees clockwise. Alright, so 90 degrees clockwise. Well, this is inconvenient. Alright, so 90 degrees clockwise. Does anyone feel confident and want to come up here and draw what they think that point's going to look like? Chris, go ahead and come on up. So taking this point and rotating it 90 degrees clockwise. That's what I do too. Very good, very good. Raise your hand if you agree with Chris. So, again, you can use your head and literally tilt and imagine it going sideways. Some other tools that students have used in times past is if you think of this kind of as a block. If this block falls over, where the whole thing rotates, so then it comes down here like this. On the right side ends up being on the bottom side. So that's another method that some students have used. Also, some students think of it this way: up 4, over 1, over 4, down 1. Think of it that way. Some people will just take kind of that L shape and flip it around. So those are kind of common visualization ways. Yes.
Isn't there also a way where you could, like, every time you flip or every time you switch, or like every time that you add a 90 degrees or something, you just flip the 1 and the 4 and then you make 1 at
Close. We're going to take a look at that rule. So let's take a look. It started off as 1, 4. When I turned it, what is this new point here?
4, 1.
4,
Negative 1.
negative 1. So if you notice, if we start off with x, y, when it turns 90 degrees clockwise, what happened to these?
X negative.
They flipped.
We flipped, and
Make a negative.
your x value became negative. So we flipped them, and your right side got negated. Okay? So for 90 degrees clockwise, you can think of that tower falling over, moving the shape, moving your head, moving your paper, or taking that rule x, y becomes y, comma, negative x. Okay? So that's true for every time you do 90 degrees. And it doesn't matter which quadrant you start in. If you flip them and negate the right side, you'll get that 90 degrees. Now, the SOL, you cannot pick up your computer and turn it, so you do have to leave that put, but you can always turn your head, you can draw the picture on a paper and turn that.
Well, like, I don't get
But you cannot turn the computer, you must leave that put.
Will I fail the SOL if I turn my computer?
Yes. Alright, so now let's go another 90 degrees, okay?
So it's like,
Negative. Totally.
yeah.
How much is this from the original? 180. Okay, so another 90 degrees from here, or 180 degrees from my original. Who feels like they can draw what this point would look like rotate 180? I'm sorry, I saw Charlie first, but I love the enthusiasm. Thank you. Raise your hand if you agree with Charlie up here. Good. So again, if you think of that block being flipped completely upside down, now again, remember it gets rotated around that origin, so this whole thing gets flipped upside down. Or think of turning your paper upside down or turning your head. Now, what is my new coordinate point here? -1, -4. So if I were to write a rule, what happened from my xy to here? Did my x and y flip-flop? No, they stayed put, but what happened? They both got negated. Good. So 180 degrees from my very original, I just simply negate both of them. Yes, Jacob?
Couldn't you just flip the X and Y and then like apply the like rule for the quadrant? Like the top right quadrant is positive, bottom
If you
right.
flipped x and y, you would have 4, 1, and then if you applied your rule for the quadrant, it's 4, -1.
Oh yeah,
Which
you're
would not
right.
make sense. Alright, questions on that? Now let's go ahead and go one more 90-degree rotation.
260.
How much is this going to be from my original?
Wait,
9.
it's 90 because it's 1
Charlie, are you?
Wait.
We've gotten one more 90-degree chunk. 180 plus 90 is 270. 3/4 of the way around my circle is 270. Yes, ma'am.
So isn't it just like 180 from the second thing there?
Yeah, 180 from here. You're correct.
Wait, well, that's not.
Going back to my very original, though, it's 270. All right. So does anyone feel confident? Go ahead. Or Jake. Jake's going to come up and draw what he thinks the result will be for 270-degree rotation.
360 just be like the original.
Oh, thank you. Raise your hand if you agree with Jake,
I know, yeah. Why did I go in
Wait.
because I put it in green.
That's right.
Good. This is indeed my rotation, and again, if I were to draw that block, kind of visualize that block getting turned all the way around.
That blocks the
Then 270 degrees. Now, what is my coordinate point for this?
It's like a clock.
-4, 1. -4, 1. Now, again, going back to my very original, how did my values change?
Positive,
Flip flop,
negative.
and what else happens?
Wait, so if you memorize that in the SOL, can you just do that instead of like...
I'm not gonna remember.
What about? Wait, this
Alright,
is
so
rotation, not
this is rotation. Again, from my original around, X and Y got flip flopped, but now Y got negated. Hold your thought, Jackson. I want you to say that in just a moment. Questions on what we have so far? Okay, Jackson.
Isn't that just the 90-degree turn?
But where? Which way?
counterclockwise.
Yeah, counterclockwise. So as Jackson said, this is 270 clockwise or just simply 90 degrees counterclockwise, which I think it's easier to visualize the tower falling over this way. Okay? So we can, right now we're talking in terms of clockwise. We'll also talk about this in terms of counterclockwise. All right. Now, Tashin, what happens if I go one more? How many degrees is that? And if I take my original, go 360 degrees, what do I get? The exact same thing. Okay? So 90-degree rotation, 180-degree rotation, 270, 360 gets you back to the beginning. Now this was all in terms of clockwise. Let's go and fill out these on the front side of your notes. So everyone on the front side, we're going to fill this in here. These are all clockwise. Before we fill it in though, 90 degrees clockwise, how much would that be counterclockwise?
270.
270. And if I'm clockwise 180, how much is that counterclockwise? Still 180. And if I am clockwise 270, how much is that counterclockwise? Okay. So again, going just clockwise 90 degrees or counterclockwise 270. We said that we switch them and negate that right side. Was that what we wrote? It is. Yeah, okay. And then clockwise 180, what do we do? They both got negated, good, so negative x, negative y. And then finally for clockwise 270 or counterclockwise 90, what do we have? Good, negative y. X. Now this is the straight formula you can use to go from your original point turned however much is indicated. Now I want to show you the pattern though. If you struggle with remembering this, you can just memorize it straight like that. But I want to show you the pattern that happens here. If I start off in the first quadrant XY, and again, you don't have to be in the first quadrant. It's just your original point. When I went 90 degrees, notice that it switched and negated the new right side. Right? I switched them and then I negated the new right side. When I went another 90 degrees, from here, I switched them. And guess what? Negate the new right side. All right, let's see if I'm practice. And then to go another 90 degrees, from here, you switch them and negate the right side, so that now becomes a positive x. And if I finish it out to go that 360, I would switch it and negate the right side, so now it becomes a positive. So you can use this to figure out that pattern, but notice this builds upon the previous rotation, whereas this gives you from your original point. Okay. I like to use this. This is my starting point. That's my original. So then I like to start here and say, okay, well, how much am I churning? Am I churning 90 degrees clockwise or 90 degrees counterclockwise? And that's the rule that I want to do. So when I go through and do these, I start off by just drawing this to help me remember that pattern. Switch, negate, right, switch, negate, right, switch, negate, right. And then I look at there to decide which formula to use. So again, you can just use it visually. You can use the straight formulas from your original, or you can figure out that pattern and go from there. Questions on that? Whichever method works best for you. Okay. So let's go ahead and take a look at this first one here with our triangle. It says triangle RST has vertices at R being 0, 3. S is 4, 0. And T is 0, 0. Since they did tell us it's a triangle, go ahead and connect that together to be a triangle.
Like, I can't tell which one is which.
I've really hard time counting one.
Yeah, I can't say.
All right. Here it says find the coordinates of the vertices after 90-degree clockwise rotation. So I'm going 90 degrees clockwise. So again, you can use it visually, or you can use the rules above. I want you to go and try this.
Wait, how would
Wait, what were you?
So you can either do it visually or use the rules from above. We're going 90 degrees clockwise. So if I do this visually, this tower, 3 high, falls over, and so now it's 3 wide here. It's on my axis, so when it turns, it stays on the axis. Now S here is 4 across. Try again. S here is 4 across, so when I rotate at 90 degrees, it goes 4 down. And T, well, it stays put. It's on the board. So this whole triangle got turned. Okay. Now, if I were to use my rules with this, remember for 90 degrees clockwise rotation, we're just switching negating one time. So 0, 3 would become 3, negative 0, which is just 0. 4, 0 would be flip it, becomes 0, negative 4. And 0, 0 becomes 0, negative 0, which is just 0, 0. If I look, these should match. R prime is 3, 0. S prime is 0, negative 4. And T prime is 0, 0. So that's my new shape. Again, you can use either method, whichever works best. Questions on that? Okay. So now I want you to try this one. Let's go with it going clockwise. And once you get this, I want you to go ahead and do this bottom one. And let's also go clockwise for this. Yeah, it's dead clockwise though. These ones did the same. So I want you to go try these two going clockwise. And again, use whatever method you prefer. If you would like to do visualizing it or using the rules, whichever you want.
Is this all in
Alright, so triangle FGH. Quiet down. Key thing is to first draw the triangle correctly. That will make a difference. Alright, so triangle FGH, F is negative 1, 2. G is 0, 0. And H is 3, negative 1. What type of triangle do we end up having here? An obtuse. Alright, so now again, you can visually do this, or if I go ahead and switch and negate my points. So F prime, we're only going 90 degrees, so we switch and negate once. So 2, positive 1. Switch and negate the right side, 0, 0. And H, switch and negate the right side, negative 1, negative 3. So when I do those, again, if I think of this block, when it falls over, it should end up down here. So that 2, oh, I lost my negative 1. Nope, I messed it up altogether. Let's try it again. This falls over. So I have, when I switch, I have 2, negative 1, but I want to negate the right side, so 2, positive 1. So there's my F prime. G prime was 0, 0. And H prime, when I do negative 1, negative 3. When I graph this triangle here, it should still look like the original shape. It should still be an obtuse triangle. If you were to graph this, perhaps you might have messed up your H. Say you messed up your H and you thought that it was down here. When I graph this, I see it does not mimic my first original shape. As we saw in our notes, or as we saw from reading the textbook, translations, reflections, and rotations are all isometries, meaning it should give you back the same shape, just been moved around. But if I do not see the same shape, that means I messed something up, because rotation should still give you the same shape, just turned around some. So let that be a way to help you out in knowing if you messed something up. Check that your final product, your image, is the same shape as your pre-image. So that should be my answer. Questions on that? Okay. So now when we go down to this bottom one, it says regular quadrilateral MATH. What is a regular quadrilateral? The angles and sides are congruent, which means it is a what, perhaps? So this one we have, it's a square. What do we know about the diagonals of a square? They are congruent, they are perpendicular, and they bisect each other. So we have that our diagonals are congruent, we have they bisect each other, and we have that they are perpendicular. So when it says a 90-degree rotation of H about the point R, would a 90 degrees be 90 degrees here? So what does H become? M. 90 degrees, it goes to M, because this is 90 degrees here. How about a 180-degree rotation of M about R? Good. T. And then AT, the side length, side segment AT, 270 degrees. MA. I do believe that sound effects are necessary with transformations. And HM, if I go 360 around here, HM. Okay. Questions on those? Alright. Now before we go the back side, I want to read something to you out of our wonderful textbook.
Oh. I was just about to say, look at that book time like.
Alright. In our textbook, section 9.3 are our rotations. And the textbook says the following. Unless stated otherwise, rotations in this book are counterclockwise.
Why?
Somebody, will you verify that I'm not lying to you guys and that is what it says? Okay, so unless stated otherwise, rotations in this textbook are counterclockwise.
Why?
We are going to write this at the top.
Can I write up the
Pearson sucks.
Alright, make this note at the very top. Unless stated otherwise.
Oh my god. This happened to us already.
Can I write it at the bottom?
Alright guys, during the SOL, during assessments, you need to do sound effects in your head.
I can do a quiet with the best.
No, in your head. Unless stated otherwise, go counterclockwise.
Is that like apply to like all the stuff you give us too? Or just in the bottom?
So we're going to follow that rule. We are going to follow this rule in here.
Wait, counterclockwise?
Counterclockwise.
A lot. That's.
Now, so a student brought up the point that if you think of your quadrants, they're labeled in a counterclockwise fashion. So that could be why also when you get to pre-calculus, we start off here, we go counterclockwise. I'm not sure if that's really the reason why, but we're going to go with it. Now, it's unless stated otherwise. So here I told you which direction to go so that we could go clockwise. And here it's specified clockwise, so you would do the direction it states. Now, let's go and flip the paper over.
Most people do that.
And also notice we went ahead and wrote in which ones, what it would be counterclockwise.
Knock your story down.
Alright, so here when it says rotate 450 degrees about the origin, did it specify which way?
No.
Nope, so this is counterclockwise.
What's negative 90? You go the other way?
Alright, so now this first one, where it says rotate negative 90 degrees about the origin.
Which all of
Which way do you think that's going to be? Clockwise. Okay, so if it doesn't specify, go counterclockwise. That negative means you're going to go opposite. So since it doesn't specify, counterclockwise would be normal. Negative means we go the other way, so clockwise. Yes.
Is that how it works on the SOL too?
Yeah, so it'll actually specify which way. Yeah. Yes,
What is
ma'am.
Will it just be rotating at 90 degrees 5 times?
No.
Yeah, how do you do the 445?
You'll get a chance to try it. Think of it as
450.
half of the 90
Yeah, you
degrees.
I don't get this.
Oh, would you say 450? Or 45?
450.
Oh, for 450. Yes, you're correct. So let's talk about 450. 450 degrees. How much is one revolution? 360. So if I subtract 360 from here, how much is left over? 90 degrees, right? So 450 would be one full revolution and then another 90 degrees.
So
that's
basically
just-
So
one.
it's the same thing as just 90 degrees counterclockwise, right?
Yeah.
Now again, you can choose whether you want to think in terms of counterclockwise or clockwise. This would be counterclockwise. What would that be in clockwise motion?
Oh.
270. Yep. So again, you can think of it either way. So when you use your rules, it's still the same rules that apply. Again, what I like to do is first set up my pattern here, start at my starting point, and then decide, okay, that one wanted counterclockwise 90, so I would then use this rule here. If it said, for example, rotate negative 90 about the origin, so I start off here, negative 90 would be clockwise 90, so then that means I would use this rule here. So for you, you can use visualization, you can use this pattern, the rules, whatever you would prefer. But at this point in time, I'm going to have you pair up and work on these shapes on the back side with your partner. Let me go ahead and split you guys up for a moment. So as you are working on the back side, notice they did not label the shapes for you. So sometimes it's helpful to label those shapes so that as you move the points, you know what you're moving. Also, when you move 2 points, connect the line in between so you can create that shape as you're going, so you're more likely to see if you made a mistake somewhere. So connect the dots as you go. If you need to label, go ahead and label. All right, let's go ahead and take a look at what we can get through so far. I will have the answer key for this posted on Blackboard so you can check your final responses. Okay, so our first one, rotate negative 90 degrees about the origin. Again, that's going to be clockwise 90 because it's opposite of counterclockwise. Now, as you're going through, please mark off what you've done so far and connect your dots as you go. It'll help prevent you from making mistakes. I'm going to start off with this guy here. I'm just going to use the toppling over idea. All right, so I went up 4 over 1, so over 4 down 1. And this guy, he's real nice. Over 1, 2, 3, 4, up 1, 2, 3, 4, so over 4, down 4. And I'm going to go ahead and connect this. And as you can see, this is a distance of 3, distance of 3, right? Also, sometimes it helps to think of this in 2 different shapes. A trapezoid turned sideways, that might help you visualize it a little bit better. All right, this one is up 1 over 1, 2, 3, 4, 5, 6. So instead of up 1 over 6, I'm going to go, okay, now I'm messing with it. So up 1 over 6, so over 1 down 6. 1, 2, 3, 4, 5, 6. And again, as you can kind of see that, create that half trapezoid there. So at this point, you can probably figure out that last part. All right, and then continue your way around. So as you go through, you would end up with the result of this.
We skipped to the 45. Like we always
Yeah.
Alright, so this is what my result would finally look like. And again, I know some people have a better time visualizing it as this top half gets turned sideways to this, and then that bottom half gets turned sideways to this. Okay. Alright, this guy, as we went around, so what is this? Counterclockwise 90 degrees.
Nope. 360 is a move.
Alright, so this, again, when it falls over, so it's up 2 over 1, so we're going this way. So up 2, so over 2. Okay, so put that point there. I'm going to go and do this guy next. So again, if it helps you to visualize it like this, getting turned sideways. And also, as you're doing it, you can kind of turn your paper to check as you go. Alright, so this guy is up 1, 2, 3, 4, 5, over 3. So over 1, 2, 3, 4, 5, up straight. Connect it as you go, so you can keep track what you're doing. Just a length of 2, so I'm just going to go a length of 2. And then this guy is up 2 over 37. So over 37. Nope, see, I did it wrong. Over 2, up 7. And again, you can see as the shape forms, it helps make sure that you've got it in the right place. Okay, so again, make sure your final result looks like what that shape picture is. Alright, skipping down to the bottom here. What do we have with this guy? What happens with him? Same place, 360 degrees. Yeah, that's why it wasn't a nice shape. Alright, and then rotate the negative 45 degrees around the origin. So this is going to be clockwise, 45 degrees, 45 degrees. Now, again, this is the challenge one. 90 would be exactly 1 quadrant. So go about half, right? So if it was 90, we know that it would look like that. So we want to go about halfway. So it would look approximately like this. Something about like that. This is a length of 3, but in terms of diagonals, we're not quite sure. My hypotenuse is 3 diagonals, so it's a little bit more than 3 squares. So approximately like that. Okay. Questions on this? Again, I'll put the answer key for the whole backside up on Blackboard. Actually, it's already up there. All right, so your homework then. Remember, May -1-2. That should only take you a minute. SOL problems are up on Blackboard. And then you have this rotations worksheet, so it is a good chunk of homework. Make sure you don't wait till the last minute to start on. No, it should not take that long.